so today we're going to talk about how we use the transition matrix and to use it to more predict the future and things like that. So it's used to do that, and what we need to do to begin with is we need to know what the initial state is. So they'll call that the initial state matrix. So you might write a little note to yourself that that's like the beginning scenario is what the initial state is. So like they're not going to come out and say, oh, this is the initial state. Sometimes you're just going to have to realize, oh, that's what they've just said in the beginning, it was this. So that's a way you can set up the initial state matrix. All right, so the way we use the transition and the initial state matrix is written here. So say you have your initial scenario. So if we went back to just thinking about that Bendigo and Colac example from the other day. So if I said, all right, in the beginning, they might have had, so we call it SO, state 0, before anything happened. I might say they had 100 cars at Bendigo and 100 cars at Colac. So there's my initial state matrix. So then what happens is you times it by the transition matrix to see what happens. So over here, you can see, this is what I'm doing here. I'm going to get to find state 1, so say the next month, I get the transition matrix and I times it by the SO, the original one, and that gives me S1. Now you can keep stepping on and you can go, all right, to find S2, I would do the transition times the one before, which is S1, okay, the state before. So what they can do is they can set up this formula, and this is a recurrence. So it's like your finance. Remember, we have all those S. So this is a recurrence relation or formula. I might call it relation. They might say that, or formula. Using transition and the thing. So you can see here, it says Sn equals the transition by this little s here, this Sn minus 1. That pretty much what that's a way of saying is the one before. Yeah? The state before, or the one state before. That's a mathematical way of saying if you want to find the next one, you can use the one before. So see here up here, Sn, so you see here n would be 1. So what's 1 minus 1 is 0. So there's the 0. So pretty much you can use that. Now what happens is we then later on we might want to find the the 20th month, and I don't want to sit there on the calculator constantly doing this over and over again. So then that's when we can use this other formula here to find any one. So you can see if I wanted to find, say I wanted to find state 10, I can do the transition. Now because n's 10, I do the transition to the power of 10 times what originally happened, SO. So that's how. Now what a good little trick that I always tell the kids is always make sure if what you want, so see how I want 10, the power on the transition and the number on the state should equal this number here. So 10 plus 0 is 10. So if you look over here at this other one, I'll just rub it out. Sorry. Oh, no. Yep. Sorry. The trick, so you can, sometimes they might give you state 3 and ask for state 8. So say for example, we were given state 3, we want state 8. What we would do is we're going to use the transition times, say they gave me state 3. So if I know state 3, that means to make this 8, so to make up to 8, 3, I would need this one to be 5. So does that make sense? So 5 and 3 make 8, so therefore that would be what you use. Okay, that's a little trick. So let's go down here on this example and go through it here. All right, so a factory has a large number of machines, and the machines can be in 2 states, operating or broken. Broken machines are repaired and come back into operation and vice versa. See here, initially there are 8 machines that are operating and 20 are broken. Okay, so that was their way of giving you SO. So you've seen they've set it up here. So 80 were operating, so there's O and that's B. All right, and here they've said there's a transition matrix. Now they've said determine the number of operational and broken machines after 10 days. So I've just done it up here to step you through so we can sort of explain. So here's the transition and this is SO. So if I times those two, this is S1 over here. So what you can do if you're doing the recurrence relation, this thing, you pop that into the next one. So there is S1, the transition, and so this is S2. And you can keep going, so then that gets popped in there. That would be the transition times S2, and that gives me S3. So that would be me constantly having to step it out. Now, because I just want to go straight to day 10, so I want S10. Now, I've been given the transition and I've been given SO. So to make these numbers, this number and this number add up to 10, I would need this transition to be to the power of 10. So I popped it in down here. Here's the transition matrix they gave me. Here's SO. I've put to the power of 10, and then this tells me. So what this tells me, I'm going to round it off. I'm going to say there was 31 operating machines, and I'm going to say there was 69 broken. Now, another thing needs to be careful is do these numbers, so 31 plus 69, they should add up to your original scenario, so which was 100. See how that's 100, and over here is 100, 80 plus 20. All right, so you be careful with your rounding that you don't make sure that you've still got the same amount. Now, you can see how this works. So when I did the stepping out with the recurrence relation, this is what I found S3 to be. If I did the power trick, is what I often call it, sorry. So here, where I did the transition to the power of 3 times the SO, see how that should give me S3, 3. It is the same, so it does work. All right, I'm going to pause. So here we've got another example. So they're giving me, this is the initial scenario. So they've given me SO, and you're given a transition matrix. So remember, a transition matrix is used to predict, for the future. So they told me what happened in the beginning, and then they want me to know, what happens a couple of states on. All right, so this is our transition. Now I do know this is a transition because they're adding up to 1. So another important fact to remember. All right, so if they said if the initial state matrix is SO and the transition matrix is, then S1 is. So the way I would find S1, state 1, is I'm going to do the transition matrix times SO. Okay, and so into the calculator you would just type out this matrix which they gave you, 0.35 and 0.55, and you times it by 60 and 75, and that's going to give you the state matrix for S1. So I'll just show it on the calculator. So okay, so we just found out that this was S1, and we just did it in our calculator and got that. All right, if we move to this example, it says S4 and the transition matrix T is this, then S5 would be. So if I was finding S5 using the transition matrix, I would have the transition times S4, wouldn't I? Now, actually, Does this say S5 on your notes? Or does it say something else? So if we were given that, that's how we could work it out. So what I'm saying here is if we look, when you have the transition just sitting like that, it's actually to the power of 1, and this is 4. So I'm saying 1 plus 4 should give you what you want, which does. So 5. So when you look down here, to calculate S5 using matrix S3 and the transition, that's what they want you to try and work out. So if I was doing that, I do the transition, and I've got S3. Now they want me to find S5. So if I want to find S5, then this number here, here, and the power need to add up to 5. So what power would I need to add, raise the transition matrix to? Can someone tell me?
2.
Yeah, 2. So good. So 2 plus 3 gives 5. So you look at that, so that you want to multiply S3 by the transition by the power of 2. There, that was a multi-choice. I think this actually was a different question up here, sorry. It was probably, we just had to find S5. We'll just leave that. All right, just with this example, I'm only going to go up to the start bit. So they've said that they've worked out this transition matrix that we'll use to predict what will happen if it will rain and if it'll dry. So here's just a few little notes about transition matrix, which we've already worked out. So used to predict what will happen in the future. It shows a changing from state to state, and it's always square, and the sums each equal 1. So if we have a little look here, that's good here, 1 and 1. Excellent. So this transition here, if I, like, it's written in a table, but it's actually a transition. So if I wrote it out like that, we have 0.7, 0.3, 0.5, and 0.5. And they're saying that this is the chance of rain, the chance it'll be dry, chance of rain, dry. Okay? So, and there's a little diagram. We've got both. So we've got it all there. And they've said the present set of conditions for the situation is always the state. So what they're going to say is they'll give you here. They'll tell you this shows the rain on the initial day. So sometimes they've told you if this one will be a different one. So if you say it was a chance of rain or if it's dry, they might say on day 1, or initially, sorry, they might say initially. So they might say initially it rained. So they won't give you the state matrix, but because you know it rained, when you're talking about chances, if it's 100% going to rain, then it would be a 1 and 0, that it rained and it definitely wasn't dry. There was 0 chance it was dry. We knew it rained. And then that's what they're saying. So then they used that to get the next day, and we're looking down over here. And I might go into that next lesson because I didn't want to talk about the steady state yet. I want you to go practice this state matrix first. Okay, so what we saw is we got up to here, and we saw that when we use a transition, we can get the next state. So with this raining, we could predict, say, if we wanted to predict state 3, which could be the 3rd day after we started, we can do the transition to the power of 3 times what originally happened. Okay, and that's how we can use. So what we're going to see down here, over here, down here, we're showing you, it's showing you what's happening after state by state. So they get to day 7, and there's what gets produced. So we'd say it's 62% chance of rain and 37% chance it's dry. And then you keep going, and there's day 8, there's day 9. Now all of a sudden you see that day 9, day 10, these 2 days start being the same. And what you're going to see is eventually you hit what we call a steady state. So a steady state's when after so many transitions, you hit a steady state. And that means that's generally the trend. That's what's going to happen. So this steady state reached at state 9. And then we can see that by state 10. And so what we would say, if they said what's going to happen in the long term, so this is another word they use instead of steady state. So in worded questions, you'll see in the long term, we see that the percentage that it'll rain will be, say, 62.5% that it'll rain in this place, wherever we're doing this study, and we're seeing 37.5% that it's going to be dry. Okay, so that's and see, I think they just said down there, they've used the word long run. That's another one. So long term, in the long run, steady state, all mean the same thing. All right, so what we have to be careful of, though, I'm just actually going to add a little page in here. What we have to be careful of is when we're proving this, proving the steady state. So if they ask you to prove that a certain state is you're at the steady state, what you should really do is say in that example before, I might have state 8, and I'm just making these numbers up. So say that was 58 and 20, whatever. We get to state 9, and we might get to, I'm making these up, 60, what was that? 78, so 60, 18. Okay, so then at S10, we see that it is 60, 18. Okay, and so would S11 would be 60, 18. So we've reached the steady state. So when you reach, so here we reach the steady state. But to prove it, you would have to show that the one before wasn't the steady state. Then you show the steady state and then the one after. Okay, so really to prove it, you should be showing 3 states to show that it is the steady state. Or if they say, did the steady state reach at 9? Yeah, there it is. Now, if they say you're at S12 and we've still got 60, 80, and say you're there and they say show that is the steady state, well, you can show the one before and the one after, and you can just say, I must be at steady state because the one before and the one after are still the same. So you might not be proving that it actually occurred at that actual state, but you're showing that this is proving that you're at steady state. So just be careful that it comes up in SATs and it comes up in exams, and unless you show those 3, you're not really technically showing that you understand or you know that it really is at steady state. So make sure you do that for that one. Here we go. So now we've now learned about how this steady state. So in the steady state, it's often called long term, or we might also call it in the long run. Just pop that up there so you know when you have questions that aren't directly asking you for steady state, that's what they might be using. All right, so how do we find the steady state? Is we can just put the transition to a really high power. So if I want to find the steady state, what I'm going to do, and this will work every time with you, if you do the transition to the power of 50, that's a high power. You've gone through a lot of states. You're going to always hit the steady state when you're using power of 50. So then times SO. Now you can times it by any state. It doesn't have to be the original one. It could be, you could have state 3. As long as you times it with the high power, you'll reach the steady state. So you can do like that. So if I'm telling you now, if you're going to go find the steady state, you're going to use to transition to the power of 50. Try not to use too much higher. The calculator will sit there for hours trying to work it out. So we don't want to clog up our calculator. So 50 should work fine. So just be careful if you were going to have to prove, like you've gone and calculated what's steady state, if you were proving, I would hope to see that you're going to show me state, because I'm going to say 49, and you might have an answer. You'll show state 50 equals that, and you'll show state 51. So show one before, one after. You won't get marked for showing too much, but you could get deducted if you don't show it. So let's just make sure we do. All right. So once you know the steady state, you don't have to actually go calculate them. Just write it down 3 times. All right. So let's have a look at this example here. It says, if an initial state matrix SO is this one, 60 and 75, and the transition matrix is here, then the steady state is. So how am I going to calculate this steady state? I am going to put this into the calculator. Now they're not asking me to prove it, they're just asking me to find what it is. So I'm going to pop that into the calculator to a high power, times it by the state they gave me, which was actually the initial one, so it doesn't matter, and we'll work that out. So I'm going to do this on the calculator with you. So we've typed that in and we get this answer of, I'm just going to say to 1 decimal place, not even, I'm going to just round up, 76 to a whole number and 59. Okay, so there we go, and that's our that is our steady state. This is what's going to happen in the long run. So it's just say this was like if we were talking about those broken and operating machines, we'd say in the long run there's always going to be 76 broken machines and 59 operating or whatever like that. All right, so let's do a couple more. So here's another example. It says there are 3 brands of chocolate that dominate the market, brand A, B, and C. People change from one brand of chocolate to another all the time. The transition matrix is shown below. If there were initially, now here you go, like they're giving you a state here. When they say initially 300 A, B, there was 425 and, 250 for B and 425 for C. What was, and you can see now the question, in the long term, the number of people using each brand. So that is a way of saying they want me to find the steady state. So I need to put some state into it. So here you can see they've actually given me initially. So initial, I can set that matrix up. This would be A, B, C. There was 300 at A, 250 at B, and 425 at C. So if I called this the transition matrix, the way I'm going to find the steady state is I'm going to do that transition to a power of 50 and I'm going to times it by that SO that I just did. So I'll do that on the calculator with you guys. Alright, so we found in the long term, once we did this, I'm going to round to a whole number because we're talking about chocolate bars. So I've got 438.7, so I'm going to say 439, and I'm going to say this is 227. Okay, and then this one is 309. Now, did you see how I read? I'm going to pause it there. All right, so we found that this is our steady state. So this is actually A, B, and C. So in the long term, there will be 439 people choosing brand A, 227 for brand B, and 309 for brand C. So if you have a look, you can see, like, if we have a look here, in the beginning, C was the most popular, but now in the long term, A ends up proving the winner. So most people bought C to begin with, but we can see that in the end, everyone starts liking A. All right, let's do this. All right, so in this next one, when I'm doing down here, when buying fruit in winter, people alternate between oranges and apples. 75% of the people who buy apples will buy oranges next time, and 55% of the people who buy oranges will buy apples next time. On the first day, they gave Winter 85 apples and 120 oranges were sold, and the question is in the long term. All right, so in the blue up there, they have set you up a way of setting up the transition. So here is, I'm going to call this transition matrix, and I'm going to call oranges, apples, oranges, apples. Now, I'm going to have to be careful here. It says 75% of the people who buy apples, so I'm at apples, will buy oranges next time. So apples to oranges, they're saying is 0.75, because I don't put percentages in the transition, I put decimals. And then they said 55% who buy oranges buy apples next time. So here is 55. Now I can work out these numbers here. How can I work it out? Who's going to tell me? I know what they are. What do I know? Yeah, good. So because they have to add up to 1, I know. So I know this is 0.45 and I know this is 0.25. All right, so now I have my transition, and I can also get in the purple, what I highlighted in the purple was they gave me the initial state. Now I've got to make sure that my order is oranges and apples, because that's how I did the transition. So it says on the first day of winter 85 apples were sold and 120. So I've got to make sure I pop them in. And then when they ask me to go find the state matrix, all I'm going to do is do the transition to a high power times that SO, and let's see what it says in the long term. So we'll go do that on the back to here. So we've worked it out on the calculator, and we've seen that this is 118 and this is 87. Okay, so this was oranges and apples. Now they asked me in the long term how much is sold. They don't want that state matrix, they actually want a statement. So I'd say oranges sell 118 a day, and apples sell 87 per day or whatever. All right, as long as you write it out in words and don't just leave it in the state matrix like that. They're actually asking you a question, so you should actually write that out. All right, each week, I'm up here. Each week, 300 students at a primary school choose art, music, or sport for their afternoon activity. The transition below shows the students' choices. Now, based on this information, it can be concluded that in the long term. So straight away, hopefully you're thinking, I need the steady state. Okay, so the steady state means I'm going to use the transition to a high power, and I'm going to times it by a state. Now I've got the transition there, so we've got this, but we need to do a state. Now my state would have art, music and things, so this would be a state matrix. Now we don't know what it is in the beginning, we haven't been told, but we do know that there's a total here, a total of 300 kids. Yeah, so I'm going to show you, it doesn't matter what you do, you'll still end up in the same spot. So if I put 300 here and 0 there and did this, I'll get an answer. I'd get the same answer if I did the transition to a high power, and if I divided these kids up like that, even if I choose that, because what I'm saying, it doesn't matter what sort of state you put in, you'll reach the steady state. So let's go prove that on the calc. All right, so if I popped that in, now we're talking about kids here, so I'm going to round to a whole number. So that was 105. this one was 86 and I want 300. So this one is going to be 109. Okay, and I'm going to show, we'll just write down here, we got the same, it didn't matter. Okay, so there's what's happening, and the question says it can be concluded that in the long run, so we've still got to remember this is art, music, sport. So no student will choose sport. Well, that's not right. All students will choose the same activity and stay in that same activity each week. That's not right, because we can see they all jumble around in the transition. All students will choose to change their activity at least once. This is not right either. And the reason why, if you have a look at the transition, just have a look. It says 50% of the kids who choose art go back to art. You don't know which kids are going each week, but because there's 50%, there's some percentage that always return. Some kid may never leave. He may always stay in art. Oh my God, what have I done? Stay in art. So that one also. All right, so question 8, the public library organised 500 of its members into 5 categories according to the number of books they borrowed each month. And here they are, J's, no books, blah, 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 and all the letters represent. A transition matrix is shown below. It shows how they interact and go from, different amount of books borrowed, and that's listed here. So we've got the transition matrix. Now, in the long term, so we now know long term is another word for steady state. So we're going to find the steady state. So the steady state can be found by doing the transition to a high power, so I said 50, now times a state. Now we do have the transition, we've got that there, so we can put that into our calculator, but we don't have a state. Now, but what we do have is we know how many people there were to begin with. And I don't know if I mentioned this the other day, but it doesn't matter how you plan out the people as long as you have the total amount. Now, they did tell me that was 500. Now, because they say in the long term how many expected to be 96. So because this is a number, I need to know a number, not a percentage, a number. So I do need to know how many we had to begin with. And they said 500. So I can put 500 into this and just put 0 in the rest of them, or I could have broken them up. It doesn't matter. And I'll show you on the calculator. So I'll just pause and we'll go do this. So going back to here, so we worked that out and we can see that it was, say, 49 here, 96 here, the next one, 124, 151, and say 80. So we can see this one. Now, if we did the letters will go down the same way they did. So J, it's K. So the answer will be B. Okay, for that one. With this one, this was from 2018 exam. And I've had a look at last year's exam, which was 2019, and very similar. So things went wrong here. So it is quite difficult, and you have to be really careful that you're reading the actual questions and what they're asking. So we're going to go through this one here. So the High Roads Company this was a ongoing sort of saga in the exam about roads anyway. But the High Roads Company has a contract to maintain and improve 2,700 kilometres of highway each year. Sections of the highway must be graded, resurfaced or sealed, and the remaining highway will have no maintenance that year. Let the state matrix show the highway maintenance schedule for the nth year after 2018. So what they're sort of saying here is that that's going to be your SO, and they've written that here. So here, maybe put next to it that this is 218, just so you know, and that you remember that's 218. So the type of maintenance in sections of the highway varies from year to year, and here's the transition. So we've got our transition now. Now, this is where I want you to be really careful with the question. It says, of the length highway that was graded in 2018. So what you want to make sure that you're only looking at the graded of 2018 is what they're talking about. So of that 700, how many kilometers are expected to be resurfaced? So really what they're saying is they're trying to get you to be able to interpret that transition. What you need to know is if I go from G to R, and if I look for G to R in my transition, so G this year, R next year, it's 0.1. So that means 10% of G will go to R. So the answer is going to be 10% of the G, which was our 700. So the answer is going to be 70 kilometers. Okay, so just be careful and try to make sure you're reading exactly what they're asking. Now, in this next question, it says, show the length of the highway that is graded in 2019 is 460. Write in the appropriate things. So, obviously, 2019, I think I said 16 there. 2019 is S1. So S1 is going to be found by going the transition times the one before, SO we can use. And then you would get an answer. So we'd get this S1 and it's going to have G, R, S and N. So you could type that on your calculator and they want the answer at the G. So they wanted essentially this answer, just this bit here. But they've asked you to show how that was worked out. So there is where you're getting caught out. You need to know how you manually multiply. So I'm going to pop it over here. I'm going to say it would have been timesing. I would have been doing it here, the transition, and it would have been times this SO, which is this one here. So, all right, 700, 400, 200, and 1400. Now, can you see, if I was, and I get the answer, would be here, and I want that top answer here. So that top answer is row 1, column 1. So remember, when we're multiplying, that means we go across the row 1 and down the column 1. So what will the 700 be times by? It got times by the 0.2. Then you would add the 0.1 times the 400, and then the 0 times 200 and 0.2. So I'm using these numbers along here, and they show me how that would multiply, and this ends up being 460. So really, I didn't even have to type it into the calculator as yet. I shouldn't be able to, because I've got to show them how it's worked out. All right. So this question continued on. So the state matrix describing the highway maintenance for the schedule nth year after 2018 is given by. So here is just showing you how we get the next one, which we know. That's just the normal formula. You use the transition times the one before. So complete the state matrix below for the highway maintenance schedule of 2019. So 2019 was state 1. So the way we're going to find that is, now we're just going to type it into the calculator using the transition and that SO before from the page before. So we'll go do that on our calculator. All right, so we've done that in the calculator. So we've pretty much found 2019 by doing the transition times the 2018, the one before. Okay, in 2020, 1536 kilometers of the highway is expected to have no maintenance. So of these kilometers, when they're talking, as soon as you see that, they're talking about of these ones, the no maintenance. What percentage are expected? What percentage is expected to have no maintenance in 2019? All right, so what happened is you had 2019. So let me explain this. So we went from 2019, we had people sitting in no maintenance, and they've gone to 2020, the ones we're talking to no maintenance. So we had in 2019, we had the number, so the quantity was up here, where's no maintenance, 1490. Okay, and we want to know, first of all, we want to know how many of them went to no maintenance again. So if I need to go back to the transition and have a look at it, so I'll do that. Hold on a sec. Okay, so I'm looking at this transition, and I want to see from no maintenance to no maintenance. So from no maintenance to no maintenance is 50%. So 50% of these guys went to the no maintenance. So if I do 50, so 50% of the 1490 ended up over in the 220 amount. So that would have been, if you do 50% of 490, that's 745. Is that correct? I'm going a bit crazy here. Yep. No?
Yeah.
Yep. All right. So we know that many went. But if we go back to the question, it says of the 2020, what percentage? So here's another important word, that when you see what percentage is always, I tell everyone to always write percentage equals the amount over what the total is times 100, because then you can fill in a bit of the data. Now you knew of these kilometers, so that's your total up there. So now we know the total is the 1536. Oh God, I can't write today. 1536, and then what amount of the 2019 did they come from? And we've worked that out. That's 745, and then we're going to times by 100 to get our answer. So we'll go do that on the calc. So it says 2, and we need to always be highlighting what they're saying, 1 decimal place. So I got 1 decimal place, I get 48.5%. Okay, so that was my answer. All right, so really careful of reading the wording, and they are a little bit hard. This is question 3, I think, of the short answer. So you only get 4 questions, so it is going to start getting harder. Now, the next question, they're asking me, in the long term, what percentage of the highway is expected to have no maintenance? So they just want in the long term, but they want a percentage and round to 1 decimal place. Because they just want a percentage, we might as well, when we work this one out, it'll make your life easier if you don't, because we don't want numbers, we won't use their original their original state matrix, because they're saying a percentage, I'm just going to put in a state. So I'll still have the 4 sections, obviously, but I'm going to just put 100 in there, because 100% would be everything. And then if I do this transition to this high power, I'm going to see where it ends up being, okay? And it will write it as a percentage for me. So let's go to do that on the calculator. Okay, so I've popped that in, and I end up with, this is the steady state here, and it says round to 1 decimal place, so this one will be 16.0, 14.4, what's it, 12.9, and 56.7, and they wanted the no maintenance, so that's the bottom one, and because I can just write 56.7%. So if they're asking me for a percentage of the long term, just put 100 in one of your categories and zeros everywhere else, and see how the percentages, how it pans out. Alright, so question 3. In 2009, a school entered a Rocker-Stedford concert. When rehearsals commenced in February, all students were asked whether they thought the school would make the state finals, yes, no, or undecided. There we go. So first question up, how many students are in this school? Well, every school they've got every answer there, even if they don't have an opinion, they've undecided. So really you're just adding them up, and they're just checking that you understand that. So what's that? 280, 300, that's 500 students. Yeah, that adds up to. Okay, each week they change their responses, and here we've got a transition. Now the following diagram can be used to display it, and they've got one missing, and they want me to fill that in. So be careful, don't miss this question. It says complete the diagram. Lots of kids miss it because it doesn't have a line underneath it to answer. So I'm going from no to undecided. So from no to undecided, that's 25%. So I pop that in there, get my answer. All right, the next question. Of the students who respond yes 1 week, what percentage are expected to respond undecided the next week when asked whether they think the school will make? So they're pretty much still testing you on if you understand this thing. So you're at yes, what percentage are expected to respond undecided? So you're looking to go to undecided. So there you go. And there we go, 5%. It said of those students, yep, what percentage? I'm just making sure they're asking me what percentage. So 5%. So in total, how many students are not expected to have changed their responses at the end of the first week? So if you think about it, so if you don't change your response, that means you could have gone from yes to yes, like you would have been no to no, or undecided to undecided. So if you look at the percentages for that, yes to yes is 85%. So just do that. No to no is 40%. And undecided to undecided is 10%. Now, we've got to be careful though. They're asking me how many, not a percentage. So really, I want 85% of the yeses. Now, they said in the first week, so yeses, there was 160. 40% of the no's, which was 120, and 10% of the undecided, which was 220. So I'm going to work out those numbers and then add them up. All right, so we've found all those. Okay, C. Now, evaluate S1 with T times SO. Is the state matrix, where S1 is the state matrix at the end of the first week. So you just have to evaluate. So all you have to do is just do S1 equals, and you don't have to write out the whole matrix. You can use their symbols. You can just show what you did to find it, and then write out your answer one, which will be yes, no, and undecided. Okay, so this is the only one you have to write the numbers in. Just use the letters that they've used for that. So we'll do that on the calc. Okay, so we did that on our calc, and we got 3, 10, 130, and 60. So we type that in. That's all that you need. And how many students are expected, so how many, that's a number, are expected to respond yes at the end of the third week when asked a thing? So really at the end, this was the end of the first week. S1 is the first week. End of second week would be S2. End of third week means we want S3. So how can I find S3? I do S3 can equal the transition times the power of 3 times SO. I'm just going to always try to use what they give me. And I get my answer. It'll be yes, no, undecided. So we'll do that on the calc. Okay, so we've worked that out, but the question was just for, what was it? Yes. So how many? So 3, 6, 1 for that. Okay, so question 6, a water park is open from 9 a.m. until 6 p.m. There are 3 activities, pool, slide, and water jets at the water park. Children have been found to change their activities at the water park each half an hour as shown in the transition matrix. If a group of children has come to the water park for the whole day, what percentage of these children are expected to be at the slide at closing time? So I've got my transition, and because they are asking me for a percentage, what I'm going to do is I'm going to times it by a state matrix that has like we're going to put the kids in a percentage. So I'm just going to put, well, we've got 100% of the kids, and I'm going to chuck them all at the first spot, and they're going to jiggle around. So this is in the long term. So what you could do is you see that if I raise this, because it said from 9 a.m. to 5 p.m., that would be 8 hours. The park's open, and if you have a look, they say they swap every half hour, I think, each half hour. So that means you've got 16 like states or swaps, which equals 16 states. So what I did is I just popped it to the 16. Now you actually reach the steady state when you do this at 16. They said that you assume that it's a steady state, but this one, it hit the steady state pretty low, and it's not a power we would use. So I reckon this is how I did it. I thought I'll just choose 16 and see how it goes, and we got the answer. But let's go have a look on the calculator. Okay, so we've checked on the calculator. What we did is, I'm just going to write what we did. We did the transition to the power of 16 times, and we used this state matrix. So I'll just call it S. We did S, and we got an answer of, we did percentage, nearest percentage. So this, 62, it's nearest 14 and 24. Okay, so we got that, and we also had a look, and we saw if we did the power of 50 times that state matrix, we also got the same. So I just checked, also then I checked, I thought, I might try the one before to make sure if it is the same, we hit a steady state. So I've had a look, and I'm pretty happy now that it is the steady state. So I'm going to go with, they wanted at the slide, which was the second one, slide. So I'm going to take the 14%.